Today I'm going to be talking about a topic which I'm very passionate about and I've been learning day in and day out about it. But I still feel like that I've only touched about 5% of it. But I think this is something which has really not been dived into in the Web3 space. But I feel like we should have more conversation about this topic. Like primarily, I've seen people like the tech is still in its early stages, so probably that is why not a lot of people are talking about it. But yeah, I think we should have more conversation regarding this, and that's the whole point of me giving this presentation. So my topic is basically sharding, a solution to unlock the next generation of scalable dapps. Before I get started, a little bit about me. I'm Sandipan Kundu. I'm a development engineer here at Sharding, and previously I worked at great projects, and like scalability has always been one of my primary focus in Web3, and that is something which I'm passionate about, and that is something which I want to continue learn and participate in. Scalability, as I was talking about, scalability is still a pressing issue in Web3. I think we have not even yet covered 1% of what we can achieve in blockchain applications in terms of the kind of applications we want to build, the kind of differences that creates it. But with the early advent of blockchains like Bitcoin, when it was in the initial stages, it was fine. It was state of the art at that point. But I think as we move ahead, as the technology continued to evolve, we saw that there are some challenges. And then when we came to the smart contract platform with Ethereum, we even got into more challenges because of the kind of applications that was possible, but we were hitting some sort of limits. And this scalability still remains a very pressing issue in the Web3 industry. But existing solutions always had to make compromises, like no matter what kind of blockchains are already mainnet or in progress, or like there has always been a compromise. And I guess like all of you are already aware of the blockchain scalability trilemma. I feel like most of the blockchains out there have already solved the decentralization part and the security part, but they are like sometimes struggling in the scalability part. On the other hand, something like Ethereum has solved Ethereum has also solved the decentralization and security part, but then it's not scalable that much. So this trilemma is still very much in discussion, and I feel like it's still very much relevant, and it still isn't being solved. And that is because one of the technical issues, like the technical roadblock, which was happening so far. But something like a solution like a sharding can help us overcome that issue. So here's a meme, like don't get it personally, like I still love Ethereum, like I have a lot of respect for Ethereum, but this just shows the current scenario of what the industry is happening. Like we have a awesome blockchain which is decentralized and secure, but it's just not able to cope up with the kind of traction which the industry needs to really gain that much of adoption. So let's come to the topic of scaling. Like there are two kinds of scaling, like horizontal and vertical scaling. Vertical scaling is basically what we see in most of the blockchains right now, which are happening, like some of the popular blockchains. I won't take names, but you can through the points you can see you can imagine what those blockchains are, in which it's trying to scale up vertically by increasing the capacity of each single node, by increasing the hardware requirements of each single node. And as it makes sense, like that's the first idea that comes to our mind. Like if you increase the hardware capacity, like if you increase the CPU, the the RAM, like you are able to process more transactions. But what happens is that it's still limited by the maximum capacity of a single machine in an unsharded blockchain. And it's a limited throughput, like it can scale up to a certain point, and after that it again stands up, and we again come to that same problem. And this is how we have come around, again I won't name names, but some blockchains having validated clients which requires 96 GB of RAM. Like you can't expect a common person to have a computer which has 96 GB RAM. So that is that limits the number of people who can participate in your network. And in that we come to the horizontal scaling solution, in which you don't increase the capacity by increasing the capacity of each node. Instead, you add more nodes to the network. And this has always been a challenge, because as you add more nodes to the network, the communication becomes more complex than even the cost also increases significantly because each node is already expensive, and you are like adding one more node, and like hundreds of more nodes. If you do that, like it's even going like the cost is getting multifold. So that is also not a solution. So that's why like with the horizontal scaling, the hardware requirements are significantly reduced because instead of having one single node going through more capacity, you're basically distributing it to more number of nodes with less capacity. And that's basically how you can theoretically be scaled indefinitely, but nothing is indefinite in the world of computer science. So there will always be limits, but we only need to scale up to the point in which we just match to the Web2 companies like limits. We don't need to scale like indefinitely. That's the whole point. Once we are able to achieve that, I think we will be able to unlock most of the solutions which we can build on Web3. And yeah, higher throughput and decentralization. Like this part, how it comes to higher throughput and decentralization, it is a combination of sharding also, which we want to talk in some of the next slides. But that's the difference between horizontal and vertical scaling, and that's how like those. So vertical scaling is currently the present solutions, and horizontal scaling, which I think will be the future. Coming to the current scenario of the state of the blockchain. The state of the blockchain is basically like blockchain can have like a state can be of multiple folds, but at a single point of time, a blockchain can have only one state. A wallet address, if it has 14 ETH, it shouldn't exist in the part of the blockchain that some of the part of the blockchain is saying this wallet address has 13 ETH, and some of part of the blockchain is saying this wallet address has 11 ETH. Everyone needs to come to a conclusion, and the state is only one true value of everything in the blockchain. So the current scenario is like every node is basically storing the entire state of the network, and any changes is propagated to the entire nodes. Like you can understand what can come as an issue with this kind of a solution, right? It's pretty clear like what can happen at a certain particular point of time, that there's a lot of redundancy. Everyone is working on getting that same transaction process. Like that is not an efficient solution by any means. But when these kind of solutions were like implemented, they were like cutting edge at that time. But like we are moving forward day and day, like in the next level of scalability. So this won't this is old school now. This won't work in the future. And state verification involves like checking the entire state of the network again. Like all nodes have like what if you have run ETH and an ETH node, you wouldn't you know like you need to sync up to the latest block, and even that takes so much time. So like this is nowhere like a optimal solution, and the state can be less performant as all nodes need to present, like as I said, need to process all transactions, and they come to a conclusion, and then the transaction gets verified. So this is the current scenario in which most of the blockchains are working through. Now coming to the concept of sharding. So sharding is actually not something Web3 related also. Like it's a concept in computer science which has been around in databases for quite a long time. It's just the conversation we are starting to have like in the past 2 or 3 years in the Web3 space. Like it's been a fairly complex kind of a method to implement in a blockchain kind of an environment. But that is like as we come closer, like more innovative solutions coming in and multiple blockchains are approaching to it, and like in some of the next slides I'm going to like cover also like how some of the blockchains are approaching this concept. But yeah, that's the basic concept of sharding is having the entire network, which we saw in one of the last slide, dividing it into smaller compute state in which like it's basically a smaller blockchain and multiple smaller blockchains communicating together to form that one large blockchain. What happens in this case is like instead of the entire network coming to a consensus that hey, like Alice has paid Bob $5, only you bring in Alice and Bob, and you only compute that, you group them together into one shard and compute that transaction and send that this state has changed to the entire network. The entire network doesn't need to know that what has happened. And now on the other side of the thing, we saw how state is defined in like unsharded blockchain. Now in a sharded blockchain, as I mentioned, each shard only stores a portion of the entire network state, making it like much more scalable and much more easier to scalable. Also, it like adds a level of complexity, and that is the reason why you will see like most of the blockchains have either like they have like implemented sharding in some way, but not in a full scale way. And like because like the data, like I'm going to cover the problems also, but yeah, that's each shard only stores a portion of the network state, This is more performance since load can be distributed across multiple. Load distribution is a very important concept even in Web3, even in Web2 state. You cannot have every single transactions being processed by every single nodes. That is not a great way to scale into the future. And like this is how, like if you, like for example in shard 1 in this diagram, the shard 1 only stores the relevant data in which like it's about to compute. So if it's about to compute a transaction from me to one person, like the shard 2, shard 3, shard 4 are not at all involved with that transaction. Only shard 1 forms a consensus group, brings in all the wallet addresses and the details, and they participate in the transaction. So this is how like state in a sharded blockchain is managed. And like as I'm going through this, I'm sure all of you are thinking that this is a no-brainer. Like why has this been not been the case since day one? It's because of the technical challenges which we are just about, I won't say like we have overcome also right now, but we are still, like sharding is still in a research phase in Web3, and we are still just getting into solutions. Some of the case studies, obviously getting started with Ethereum. So Ethereum with its ETH 2.0 roadmap had sharding as its one of the stages. But sharded chains, it was I think planned that 64 sharded chains, Ethereum will be divided into 64 sharded chains. But like it's no longer in the state sharded chains is no longer in Ethereum's roadmap, and instead they will be doing like something called proto-dank sharding. So basically, to give you the simplest and straightforward explanation of proto-dank sharding, what happens is layer 2's layer 2 rollups dump their transaction on the Ethereum mainnet, and they dump that using call data, and which is gas intensive, and also it stays in the network forever. What happens with proto-dank sharding is proto-dank sharding adds a blob of data to every single transaction. So like you have the normal transaction and then you have the blob data, and that blob data gets using that storage you can dump more data. So layer 2s can dump more data into when they commit to the Ethereum main chain, and using that the gas fees in layer 2s can become even more cheaper effectively. We still this is still an EIP is just introduced about this, so it's not yet implemented, but we will see how much that impacts. But again, this will only make gas efficiency in layer 2s. This will still not add TPS capacity or throughput in any sort of way. So, but it's still Ethereum is making one step at a time towards that. But still, sharding is no longer in Ethereum's roadmap, because Ethereum saw that layer 2s are catching up very fast, more fast than they thought. So that's why something like this is being implemented. And also implementing sharding in a live blockchain is much more difficult than starting a new blockchain and implementing that. So that is also one of the reasons that's why Ethereum has pushed that down. Then comes Near. Near has an initial implementation ongoing with their Nightshade protocol. They have an excellent documentation and a whole page in how they have shown on how they're planning to do it. But still, even with Near, they are still running they're effectively running a sharded blockchain with only 200 nodes, and that is not a very scalable, not a very security or decentralized way kind of doing things. But they still have a very long roadmap, and we can see how that works out as we move forward to the future. But Near is also a blockchain which is trying to implement sharding in their ecosystem. And then we have Polkadot, a different kind of mechanism in which instead of adding more nodes, they create more blockchain in itself with the parachain concept. But this is also getting too difficult, because parachain, I don't know if you guys know that parachain has auction slots. You need to bid for that, you need to get assigned that, and creating more blockchain is not a way when parachains ultimately still commit to the relay chain of Polkadot. At the end, the solution there are solutions which are going about and then causing the same problem at a particular different region. So it's not the actual solution, but it's just pushing the limits one bit at a time. But also with limited parachain slots, this is also getting very difficult, and they still rely on the relay chain. So these are some of the blockchains which have given a shot or even removed in case of Ethereum on how sharding can be implemented in them. But there are also a couple of other blockchains. I think Zilliqa is one of the, I don't know if some of the OG people who were in 2017 and 2018 would know about Zilliqa. They also had they were I think one of the first sharded blockchain, but they didn't picked it up because I don't know because of like marketing also. I don't think like it didn't get traction is what I'm trying to say. And they were always also at that point of time the technology was not that much matured. It was still in its early stage. But yeah, projects like those paved the way for future projects. So we are still grateful for them. And coming to the project of Sharding, which I'm working in currently, so I'm going to like talking a little bit about how we are trying to use this solution and solve the problem which we just like discussed, and how like we plan to do it. So Sharding is a dynamically sharded EVM compatible L1 blockchain. So EVM can still process like one transaction at a particular time. It's like single threaded operations. It's unless like until like something like some blockchains which are doing like multi-threaded compatible like operations. But what happens is like if you can't make the engine like multi-threaded, and in that sense, what you can have is like multiple of that engine running, multiple instances of that engine are running, and that is how like we are trying to implement that in Sharding as a dynamically sharded EVM compatible L1 blockchain. We are going to talk about each of those words, what those mean, and how we are implementing that. So dynamic state sharding. On Sharding, how it happens is, for example, there is a list of in 0x1, 0x2, like consider those a list of addresses. It can be smart contract addresses, it can be wallet addresses. What happens is like those addresses, instead of all the network and all the node matching each of those addresses, what happens is like only a particular group of shards are given a particular set of those addresses. So for example, the shard 1 is given 0x1, 0x2, 0x3. Then shard 2 is given 0x4, 0x5, 0x6. Then again, like, and then shard 4 again, like the shard 4 is again given 0x1, 0x2, 0x6. So you still have some sense of overlap, but you are still getting, instead of having the entire network state in one particular chain, you are dividing it into multiple parts. So what happens is like, and like I'm going to be talking about like how we implement also, and when we discuss the challenges, like how this distribution happens by wallet addresses. So for example, and this is dynamic. Why the part of dynamic is like many blockchains have implemented sharding with like static state sharding. The main primary difference is that in static state sharding, when you are computing, like let's say you have a wallet addresses of 10, let's say you have 10 addresses and you want to track those, and there are 4 shards. In static state sharding, it's divided into the first 3 will go in first shard, the next 3 will go in this shard. So those are static and they won't till the forever. Those particular shard will only be tracking and only be processing those particular transactions related to those addresses. So that is static. Instead, what we have implemented in Sharding is dynamic state sharding. So it's not fixed that a particular shard will only compute from a particular wallet addresses or contract addresses. And that's the whole concept on how we can like not only add more throughput and also like decentralization and security, that you won't like it's secure, that you won't know that this smart contract address only lives in this shard. So this so all the transaction will only happen in this particular one. So it is randomized and adding a layer of security to that case. Each node is only responsible for a dynamic address range, which I just discussed, which may overlap with the addresses. It's overlapping. It's still overlapping because we need to have some security in the sense that what happens if one of the nodes or one of the multiple nodes in a shard just goes offline in the middle of, you still need to fetch the data. So you still have some overlap, but not everyone has all the data. So like you're still getting efficient in that sense. And this also added to the security part, which like as you know, like it's dynamically shifting, so it gets added to the security part. Then comes the concept of linear scalability. How is linear scalability achieved? Like this is how this is one of the biggest methods in which like when I read about the project, which I really liked, is like the vision about this is every Web2 applications is scalable linearly. Like if you go to any cloud applications, you can set those up based upon the traffic or the what your application is getting. But the blockchains always have a kind of layoff, which I just discussed, that after a certain point of time, it just doesn't scale above that. what happens is with the whole implementation of sharding in Sharding is like it's linearly scalable, meaning that we benefit of the number of validators joining in. So the more number of validators there is, the more number of dynamic address arrays there will be, the more number of data availability there will be, and like the more number of shards we can form. So Sharding is one of those blockchains which benefits from having more validators into the network, and it is linearly scalable. Hence the graph, like if you have more net nodes in joining the network, you will have more TPS, because essentially what we just discussed, right? Instead of making each nodes more powerful, you are just adding more computation on top of it. So that's the whole concept of linear scalability. And this is one of the other big feature of Sharding, of auto scaling. In the case that Sharding has a concept of cycles instead of blocks. We still form blocks to maintain the EVM compatibility, but we don't, because we don't do consensus on block level because it's not needed. We do consensus on transaction level. So in the sense that every 60 seconds one cycle is formed, and basically what happens is like let's say the chain is right now in low demand, like in moderate or low demand, and we are doing about 750 TPS, but suddenly there is a popular NFT mint happening, and you need like more transaction throughput. What happens is that the network every 60 seconds the network checks what's the amount of transactions that's coming in, and it brings more standby validators from active. So there are two kind of validators in Sharding. Ones are standby and one are active. What happens is as the network needs more throughput capacity, it can scale linearly with that. It can bring in more standby nodes to the active pool, and that's how like you can jump from 750 to 1500 TPS when the traffic is needed, and then again when the blockchain senses like in the next cycle that hey, like I'm not seeing more transaction in the incoming pool. We don't need that much computation. Then again, the active nodes are shifted to inactive in the standby mode, and hence, like you can again scale back to 750 TPS. So you're only using or you're only scaling up when you need that transaction capacity, and the rest of the time you are just maintaining the balance. You're only using the resources what you need, and you can always scale up when you have a higher throughput, like when you need higher throughput. So that's the whole concept of auto scaling, and how it can like it's a future-proof solution on how dapps can leverage those and make like the next gen scalable applications. So that when popular mint is happening, you can be assured that in Sharding, when a popular mint is happening, the transaction gas fees won't just shoot up just like it happens on Ethereum. And like we are just an L1 based ecosystem, we are not dependent on L2s. So that's why like it's a very important concept for us to have that scalability of dynamic auto scaling. The challenges, like as I mentioned, like this technology is still in its very early stages, and these are some of the biggest challenges which I think every blockchain needs to be aware of. And specifically, it's very difficult in a sharded blockchain with consensus, data management, and availability, and cross-shard communication. So with consensus, I know like many of you must have the question that if the entire network doesn't hold the state of all the validators don't hold the state, then how are you performing consensus? So it's the consensus only is happening based upon the shard, and the shard only forms, as I discussed, based upon the wallet addresses, the contract addresses involved. So you are only changing those states. You are not changing any other states. So you only need those parts. And if you identify that these are the wallet addresses, these are the smart contract addresses which will get involved in this transaction, and you bring them together and form a shard, and you perform consensus on that. On top of that, and like in Sharding we have POS plus POK, like Q, proof of quorum. Basically, it's a leader management in which like a leader, the entire network votes. There's one leader which accumulates all the votes and sees what's the actual state of the transaction, whether it should pass or fail, and then the data is like it's finalized. So that's how like consensus is done. That this is a challenge in any kind of blockchain, but specifically in a sharded blockchain, you do be aware of like how you're doing consensus when the entire network doesn't hold the state. And after you are done consensus, you're just propagating to the entire network that hey, like this transaction has happened. These are the new states of these addresses and smart contracts, and that gets the entire network is just informed. They are not involved. Then data management and availability, like in a sharded blockchain again, data management and availability is one of the biggest challenge. You need to ensure that whatever you query and where you query from, you get the true data. And like again, like it's a sharded blockchain. Not everyone has every data, so you need to identify like from where you get those data and pull in that from wherever applicable. So that is also a biggest challenge. And like I think we are still in the like I won't say like it's completely solved issue, but like we have still made significant process on that in data management and availability. In the case like if you go through the like we will still I think in the light paper also I think it's mentioned, and but like even in the white paper it will be mentioned that like how we are using the whole like there are validator nodes, then there are archiver nodes who are storing the entire state of the network also, because you need something like explorer to query. So that's how data management availability cycle is maintained. And then cross shard communication. This is the important part. Now you all must be also be wondering like if a shard has done a consensus, how are you communicating to other shards? How the other shards are communicating with each other? So how Sharding has implemented cross shard communication is like with EIP 2930 it's an automated access like optional access list. So what we have implemented is like every transaction that gets put into Sharding mempool, it's like a access list is generated. That access list only contains what are the wallet addresses involved in that. So just by like checking that okay, this is a Uniswap like pool contract, this is token A, token B, you are making an access list based upon that, and just through that access list you are checking the entire network who has this data. Whoever has this data, if you find a match, you bring them to a consensus group and you form a shard. So that's how like cross shard communication is happening. So you are just implementing like using that access list, which and like access list you need to define in Ethereum, but in Sharding you just can send a raw transaction and Sharding will like create that access list for you. So as a smart contract developer, you don't need any change in this solidity code. So that's how like the cross shard communication happens. And these are the like the primary three challenges, not in any blockchain, but in specifically in a sharded blockchain, and that's how like in each points we have planned to overcome that. And yeah, that's pretty much it. We have a an event also today in afternoon, so you guys are welcome to join that. Do register for that. And looking forward to more discussion about this and how we can work. This is still an early stage. There are a lot of conversation we still need to have. There are a lot of challenges which all the sharded blockchains are facing, but like as we go forward towards mainnet, I'm sure like we are able to figure those out one by one. Yeah, thanks a lot. You can get connected with me on Twitter also, and I'm happy to take questions.
So, how is this is this more vulnerable to 51% attacks?
No, so shards are dynamically created. Like it's not, you cannot just force form a shard. So like the 51%, like you cannot until you have the entire control of the entire shard. Like you cannot like change the transactions. But again, like you cannot have the entire control of the entire shard because you don't know how that shard will be formed.
Okay.
It's not up to the users or someone sending a transaction. The network does that for you.
Is there a way to find out, let's say there is an address 5, is there a way to find out which shards contain the address 5?
No, so that will, when you submit the transaction, the network will calculate that automatically for you. Like you won't be able to identify like in which shard what lives. Because you as a user, you don't need to know that. The network needs to know that to execute that. And that is a security barrier. So like otherwise that will be a very big problem if people are like, hey, like this is the shard that it contains, and then they will be trying to manipulate that. I need to force the transaction in that particular shard. And also like it's not that, as I said, like there is a layer of redundancy also. That it's not that that data is only available in one node or only available in one shard. Like there are nodes, like multiple nodes having that. But it's just instead of something like Ethereum, which has 5,000 nodes or 100,000 nodes with the same data, you have 500 nodes probably with that same data. So that's, you still have a lot of redundancy.
Okay, that makes sense. Thanks.
Is
there any limit on number of shards in Sharding?
So we will like, so the question is there any limit on number of shards in Sharding? So initially we will have like with a limited number of shards. but the Sharding DAO can control that number based upon like what the network demands. But initially we will come with I think with around
120.
yeah
120.
yeah 120 shards.
And how that number is defined? Like, is there
So initially at mainnet we are only initially at mainnet we will be ensuring that we at least scale up to 1000 TPS from day one at mainnet, and it will go up from that. And as we see more transactions and because we need to do that step by step, we cannot just immediately do it, because in the sense that there is a lot of communication overhead also, the communication between cross shard and that. So you need to ensure that those communication is also scaling linearly. So at mainnet when Sharding launches, it will be able to do around 1000 TPS, and it will be able to scale, like it's not fixed. So when it's only needed for 450 TPS, it will be 450, but it can scale up to 1000 TPS when necessary.
Okay, I have another question on the active and standby
Standby.
nodes. So in Ethereum, like I'm a home speaker, so I know that everyone gets the attestation rewards and all that stuff. But in this case, how the rewards are distributed for the standby nodes and
Yeah.
active, and how it is being defined?
So only the active nodes get rewards, and standby nodes. So every cycle the ratio is changed. So if there are 150 active nodes right now, and there are 400 other standby nodes waiting, so in the next cycle those 150 won't be the 150. It will be like it will go through a cycle. That once you have got the chance, then some other nodes will get the chance, and again in the next cycle some other nodes will get the chance. So it's a rotation. And but with that you must be having a question like how if 5,000 or 50,000 nodes are in the standby nodes, like how are you incentivizing? So it's the like the pricing model with Sharding, which we have released also SHM tokenomics in the Sharding page. You can check the graphs that after a certain point of time it will become like people will get disincentivized to run more nodes. So if you don't need that much throughput, you won't need. So you will have a layer of boundary so that you can scale. But when that scales up, you like the node rewards also increases, and again suddenly more people wants to join. Then again like the transaction throughput is no longer needed. The rewards will reduce. More people will drop out. Why will someone stay in a standby node for like forever if they are sure that like they are going to be at a loss? So that's how the economics work.
Thank you.
So my question is about auto scaling, and also in the last part talked about the challenges. Okay, but first the auto scaling. So you say that 60 seconds. After 60 seconds, the network decides that if there is a requirement for bringing in more standby nodes.
Yeah.
Now, so during the 60 seconds, the network is calculating.
Yeah, so it's like it cannot be like, so there needs to be a time period in which the network is able to scale. Like it cannot be like, so the team has come up with a solution like in an optimal, like they have decided in a time that every 60 seconds is a good amount of time in which it's good to scale up or scale down. What is the requirement? So based upon that, it's not necessary that it will require 60 seconds to compute that. It's basically a fixed amount of time in which you can be ensured that if the network demands such like certain capacity throughput, like 60 seconds is a good amount of time. Instead of something like Ethereum which won't at all, you are like waiting just for 60 seconds for the network to scale up to that and match up to that point. So it's a time value which I think the core architects have come to a conclusion that this is a good amount of time in which like we can check. It's not that frequent as 1 second, and it's not like 5 or 10 hours. So it's kind of that kind of.
So when you talk about auto scaling things, whenever the load on the network is high. So in those 60 seconds, it's not like plain 60 seconds. On the internal level, there are various phases. Right? So in the first phase, whatever validators are joining or that intend to get rotated in a particular shard, which was probably on a standby state, they vote. They submit their certificate transactions so that the others can validate, and they can validate that whether this node is correct to join in or not, or what was the last time when it was active. Right? In that phase, in those multiple phases, the network is constantly aware of what the status of the TPS is. So as per certain mathematical calculation, if that TPS goes beyond a certain point, which is obviously in correlation with the current number of active validators, the network knows. If it's not, if it needs to descale or it needs to upscale, it votes accordingly, and that vote is processed in the next cycle, so that whatever the number of validators are there in a particular shard or across shards, they can decide on it and vote and allow and increase that bar of validators per shard and allow more validators to join and submit their join requests. So that's how it works.
But this process must have intense cost, because a lot of node is calculating or participating and voting to join the shard or to scale up or scale down. So is this a security challenge that some attackers comes in and they certainly increase the transaction volume and make the network busy, or force the network to do these calculations, so voting and etc. And then suddenly when everyone has joined or new nodes have joined the shards, after that they again decrease the transactions or like just stop the transactions. So then the descale of the shards, that again starts to happen, and then they do this same thing again and again just to make keep the networks busy with upscaling and downscaling. Is it a security challenge?
So the way the network has been designed, first of all, in order to span the network, in order to make it continuously auto upscale and descale at a rapid pace, is a very difficult challenge. But let's say hypothetically, you gather around a team of huge people and they spam the network with, let's say, 100,000 requests. Right? Let's say you run a script, whatever way, you choose your way, right? Yes, whatever way. Yes. So if that's the case, and if you, let's say in one cycle you start spamming the network, in the next one you descale, the network in every cycle will not immediately vote for descaling or auto scaling up. It will take its time. It will continue that phase for a bit of time. It won't descale instantly. It will take its time and will see that, okay, whether this TPS is continuing for a certain amount of time, for a certain number of phases, and then it will vote for this. Because, yeah, you're right. Because in order to vote, obviously, the nodes, the active nodes need to decide on their own, and they need to pass this message that whether we need to auto scale or not. So yes, that's why we have not done it in a way where we're just bombarding the network with so many internal gossips that now we need to upscale, now we need to downscale, that we need to downscale. There is a breathing period so that the networks, even the nodes in the network, if they're experiencing a high load of traffic, they get enough time to breathe and see while processing all the transactions that whether we need to auto scale really or not. So that's why in order to make the network auto scale, it takes good amount of number of cycles to actually make it to that, instead of making it hurriedly do it every other cycle. That now we are experiencing 250 dps, now we are experiencing 500 dps, so it won't happen instantly.
The 60-second timeline is just the network is monitoring the network.
Yep.
That what's the situation happening. It doesn't necessarily mean that in the next cycle itself it will go from 400 to 1000. It will gradually, it will go 400, 500, then it will see. It goes 600, then it will see.
Then next I would like to ask that how does Sharding attend the problem of front running? Because I see that shards can be a very good point or a good target for the front running or back running.
So Sharding is like there is no front running in Sharding possible, because like in Sharding the transactions are timestamp based. Like the execution is timestamp based, not with blocks. It's not who pays more gas. It's like who comes first. It's a first in first. Yeah. So it's timestamp based. So that's why like there's no MEV possible in Sharding in itself. Like it's a feature in Sharding itself that there's no MEV possible. I think that the MEV economics has hurt Ethereum a lot in some sort of the way. So since we are coming as an upcoming L1, we had to see the market that what's hurting the network, and so like there's no MEV possible in China. One last question.
That there is a one challenge for data availability as well, right? So how do you solve the data retrieval, right? Because shard can be linked on any other node as well. And when you make RPC call, you don't know where the data is. So you are maintaining any data dictionary where you look for the data. Because if there is a data dictionary, again it comes to the performance, right? You have to add an extra step to retrieve the data. So how you manage that?
So Sharding architecture is not just validators, so we have called archivers also. Like you will always need archivers which has the entire network state from the zero, like from the first cycle. So from the like the RPCs interact with the like nodes, but again all nodes don't have the entire network state. So you will always have that. You need to query something. You can query that from the archivers.
But if current state is not replicated, right, over the all nodes, then how does it manage?
How does it manage in what sense?
So-
Like the consensus is done in a like each shard basis, right? Once the consensus is done and it's confirmed that a transaction has failed or the transaction has succeeded, you cannot change that, right? So there is like you are just querying it from the archiver. You cannot change the state of the transaction. That you cannot make a failed transaction succeed. It's already in.
Thank you.
Any other question? Thanks a lot.